Welcome to the second of our 4 colour webinars we are holding this year. My name is Carl and I'm going to be moderating the webinar. Today we will be talking about solutions to common problems in edible oil measurement. Before I pass you over to Peter, I wanted to mention a couple of quick notes about today's webinar. We've placed everyone on mute to cut down on background noise. So if you have any questions, you'll need to type those into the question box that's marked Q&A. We will try and answer these in our question section at the end of the webinar. Lastly, this webinar is being recorded. We will make it available on our YouTube channel, and anyone who has registered to the webinar will receive a link to the recording via email. Today, we are joined by Dr. Peter Clark. Peter is the manager of our colour laboratory. He has over 30 years experience in colour measurement sciences. He's written as well as co-authored a number of good practice guides to making reflectance and transmitted colour measurement. He's a member of the Society of Dyers and Colourists, a member of the BSI Standards Committee for the Measurement of Textiles, where he oversees all aspects of colour measurement, and also the UK representative for Division 1 of CIE, which is the International Lighting Committee. We are very proud to have him as a member of our team and excited to hear him speak today. So with that, I'm going to hand you over to Peter.
Hello everyone. So today I'm going to continue on from our first webinar. We're going to have a little bit of a recap about instrument setup, about our instrument validation, how to make a good measurement, and then I'm going to look a bit more in detail at how we understand our reported results, and then I'm going to introduce you to the Valido Universal Verification Standards. And then I will give some reasons as well during the talk as to why we might be seeing some inconsistent results. So when we talk about our instrument setup, a lot of the standards for making our edible oil measurement will mention the laboratory environment, the environment that we put our instrument in. And this is quite important if you're using a visual instrument. The visual standards will mention that you'll need to site it in a part of your laboratory where you're not got direct sunlight shining on your instrument. Having direct sunlight shining on your visual instrument means that you have this distracting light while you're trying to do the colour match. You need to site it in an area where you don't have direct sunlight. The other thing about in our laboratory, especially if we've got an electronic instrument, we might need to give our electronic instrument some sort of warm-up time. And once we've done some warm-up time, we also need to do some sort of baseline measurement so that the instrument is good to go. Another thing, a lot of our samples, maybe if we're looking at things like palm oil or coconut oil, we're going to need to heat them up. So we also need to set, if we've got a heated sample chamber, we need to set our operating temperature because it can take a little while for our instrument to reach its operating temperature. One major thing that we need to check with our instrument is our cleanliness. So if we have our visual instrument, we've got sliding glass filter racks, but these are open on the top, so it's very easy for oil and dirt to get down onto the glass rack. So we should be cleaning them, because when we slide them in to make our colour match, we're not making a colour match with just the glass. We could be making the colour match with the glass and any dirt or grease or oil that's actually on the coloured filters. So if we need to keep them clean so that we actually get a proper color match, so that the color match is the color match that we're expecting, not one due to dirt or discoloration. Which brings us on to the actual sample chamber of the instrument. You can get spillage inside, that needs to be cleaned up, but also with the light shining inside the sample chamber, it will over time start to discolor and turn yellow. This is going to then give a yellow sort of lighting to your color match. So we really need to be replacing the white insert in your instrument if you have something like a Model F. If you have an older instrument, you might need to repaint the white. And also we need to look in our visual instrument at the white reference standard at the back of the sample chamber, because this is where the light's shining off and then being reflected and coming back through our sample and then up into the eyepiece. So this needs to be nice and smooth, not have any bits missing from it, not have any coloration on it, no oil spilt on it. So we need to keep everything really nice and clean. This also applies to our electronic instruments. We need to make sure that we're not spilling oil everywhere, we're wiping up our spillages. And with an electronic instrument, you have a light beam. Here in the PFXi, the light beam is coming from the left-hand side to the right-hand side. And there are two windows on either side of the sample chamber. These windows need to be kept clean because any dirt or grease is going to affect our measurement. It's going to scatter the light. It's going to mean that maybe not enough light is going to reach our detector. And it's going to give us a false reading. It's going to probably lower the light level. So that's going to give us a darker color. So we're going to register an oil that's a lot darker than we're expecting. So we need to keep everything nice and clean. And then we have the best chance of having a really, really good measurement. The other thing I've talked about before is instrument validation. So the idea of this is that we use a filter or a reference liquid fairly often, maybe once a day with a reference filter, maybe once a week with a reference liquid. By measuring some sort of validation sample that we have a certificate for, that gives us a value, means that we can put our reference liquid in a cell, put it in our instrument, or put our reference filter in the instrument, make a measurement, look at our results, and if our results match or very close to our certificate value within the tolerances on the certificate, we can then have confidence that our instrument is performing well and is measuring well. So when we start to have problems, the issue is then not with the instrument, the issue is with something else. So it could be that we haven't heated our sample hot enough, it's not melted enough, or there's some dirt, particulates in the sample, we might need to filter our sample, or that the cell, the windows on the end of the cell, or our conformance filter is dirty. So we need to clean things, remeasure, or it might simply be that we put our sample in the wrong path length. So we've got a completely different result because we're using the wrong path length of cell. So we've got maybe a much darker or much lighter reading than we were expecting. The other thing to remember is that the Lovey-Bond scale and the ASCS red-yellow scale are logarithmic in nature, and this is due to the way the eye works. So if we double the amount of color, usually by doubling the path length, visually the eye does not see that as double the amount of color. It might see that as about 1.5 times the amount of color. So this means that as you double up the path length, you don't have this linear response. You have a what's more logarithmic response. So the darker you make the sample, the less the eye sees that physical change. So when we look at the Lovibond scale, if we're changing colour from say 2 yellow to 4 yellow, the eye is actually going to see that as a similar colour change as if we went from 20 yellow to 50 yellow. And that seems like some alarmingly big number, but because of this logarithmic nature of the way the eye sees, you're going to get this loss of resolution as your sample gets darker. So what can we do about this effect? Well, mostly it's the path length we can change. So most of the international standards for measuring edible oil will say start with a 5 1/4 inch path length on an unknown sample and reduce it if the colour is too dark. So if we look at these two, same sample here in a 1 inch cell and in a 5 1/4 inch cell, in the 5 1/4 inch cell, I'm getting a value somewhere in the region of about 50, 60. If I put it in a 1 inch cell, I'm getting a measurement somewhere here in the region of about 12. When I look at the variation in the scale, if I'm up at 50, my variation, I could have anything really recorded from about 30 to 70. Because of this loss of resolution and the way the eye works, you can have quite a big, what seems like quite a big color difference on the Lovibond scale. So what we're trying to do is what we should do is we should aim for the total of our red and our yellow and our blue or our neutral values to be less than about 20 units in total. This means that when I'm measuring the same sample, I've moved down to a 1 inch cell. I'm operating it around about here, about 12 in my yellow value, which means that any variation I'm going to get maybe 1.5 units either side of my measurement point. So I might have a much smaller variation in my sample. This is because here we're in a more sensitive region. And it's going to give us the best sort of way of measuring our sample and the best area for comparing our sample with other people. But also we now need to look at our sample preparation. And this is especially true with electronic instruments. They don't see what we see with the eye. They can't average out effects that the eye can. All the electronic instrument sees is what it sees. So what we're looking for here, we want no turbidity, so no cloudiness in our sample. The best way to look at this is to look down the length of our sample. It may be some text or some writing. And if you can read that nice and clearly through our sample, we know we've got a nice clear sample and no turbidity. Again, we will be wanting to heat our sample to make sure our sample is fully melted. And especially with things like palm oil, the graphs here show that if you're at a temperature below 50 degrees, we're going to see some blue component. If we're getting a blue component in our measurement, usually that's an indication that we have some sort of unmelted matter in our sample. So we're having some sort of scattering of the light, we're losing light. because it is not fully melted. Now I can see here, if we move on to the red and the yellow graphs, that we also need sometimes to push the temperature up to maybe 60 degrees or even 70 or 80 degrees. And you can see that for some of the samples we have there in the graph, the lines are nice and flat above 60 degrees, but for some of them they then go down again once you get up to 80 degrees. This is because the palm oil is made up of many different fractions of oil. And although it may appear melted at a lower temperature, you've still got some of those higher fraction oils that haven't fully melted. So you need to make sure that you heat the sample, maybe heat it a little bit more, watch those values and find the point where for your particular oil that you have the right temperature where you can get that lowest reading on your red and yellow. And then you know that you're at the right sort of temperature for the samples that you're measuring. So you can fully melt those higher fractions of the palm oil. So we've got our instrument, whatever that might be. We need to be measuring according to the operating instructions. And we also need, especially if we've got an electronic instrument, to pick the appropriate scale for what is required. So it could be I'm picking my Lovibond red, yellow, blue neutral, or I'm picking my AOCS red, yellow. And then we'll need to make any zero or baseline measurement without our sample in there before we then measure the sample. And then we note the sample values. But that's not the end of the story. We have our measurement, we have our values. We now need to pass that information on to someone else. So how should we pass that information on? How should we report our measurement result? Well, we need to report everything that's going to be useful for the person we're passing it on to, so that they can actually replicate our measurement and confirm and have confidence in the sample that we're giving them. So we may need to add in what we did to prepare the sample. Did we filter it? Did we heat it up? And we may have some other comments on the sample condition that may help communicate information about the sample. We also want to actually record the temperature of the sample was when we actually measured it, which test method we're using, so which standard are we following? Are we following an ISO method? Are we following an Indian standard method or an MPOB method? And then most importantly, we need to say what path length we're using. Most of the standards will assume that if you don't record a path length, that it's a 5 1/4 inch cell. But that might not be the case of what you actually use. You may have used something like a 50mm or a 10mm or 1mm even, or 1 inch path length cell. So you need to make sure that you put the path length in. You may want to communicate the type of instrument you were using. Definitely want to communicate the color scale you're using, and of course the measurement values, and then any other relevant information. And that might be information that you as a supplier have agreed with your customer, or you as a customer have agreed with your supplier, the name of the sample, the batch it's from, things like that, so that you have some way of identifying the sample, passing on the information, and you have everything that everybody needs to replicate that measurement. And then when I have my measurement result, I've got to remember that every measurement I do has some sort of associated repeatability and reproducibility. A lot of the international standards will have a section right at the back of the standard where they list typical repeatabilities and typical reproducibilities. Now, when I'm talking about repeatability, what I'm meaning is a short-term repeatability. So it's a short-term measurement, I might make 10, 20 measurements on my sample. They're not going to come out exactly the same each time. I'm going to give you a little bit of a range. And what I will do then is I will do some statistics on that. So I will work out what the average is. I will work out what the standard deviation is on my sample. And then I will multiply that by some factors to come up with some sort of repeatability. So some sort of estimate of the range of measurements. So I could be measuring my sample in my lab. I might get, what, 2.4 yellow, but I might then get 2.3, 2.5. So I'm going to end up with some sort of repeatability value that says my yellow value is 2.4, maybe plus or minus 0.1 in the yellow, which is great. So I've got some idea of how variable my measurement is from my particular instrument. So I've communicated my value to the other person, and they're going to be measuring the same sample in a different laboratory on a different occasion. It's going to be a different person. They're going to do their own measurement, and they're going to get their own repeatable measurement result with this small variation. But then we're going to look at the difference between my result and the result from the other lab. And this is where we come into the reproducibility. So we're looking at the difference between the repeatable results from one lab to the other lab. And that's potentially going to be a much bigger value, because we've got to factor in things like a different instrument, a different location, different sample preparation maybe. And so, you know, there's going to be a difference between the two labs due to this. Now, we'd like to put some numbers on it. And a lot of the standards will have within the repeatability and the reproducibility section some estimate of what these values are. Now, my reproducibility is always going to be bigger than my repeatability. So in my slide here, I have been through all the international standards, and I have sort of collated together repeatabilities and reproducibilities as given in the standards. So this gives you some idea of what the sort of differences we may be expecting between labs and what the sort of repeatabilities I would be expecting for my own particular sample in my lab. Looking at this table, we can see that our repeatability and our reproducibility is going to be dependent on what my measurement value is. So as my measurement value increases, my repeatability and my reproducibility values will also increase. So if we look at our red value here, we're going to find that as we move up to 3 and 6, our repeatability has gone up from 0.1 to 0.8. But our reproducibility with our electronic instrument has gone up from 0.25 to 1.2 to 3.5. And then similarly, if we look at the yellow measurement, we're going to find that our repeatability goes up from 0.2 at around about a 0.2 level, to 2 at 10, to 6 at 40, to 8 at 70. So we're now starting to get some quite big numbers as we go up the scale. But remind you again of the logarithmic effect of the way the scales work. So as we go up, we would expect to see bigger variation in our results because the resolution is less. And if we again look at our reproducibility, we're going to see a value go up with our yellow from 0.5 to 5 to 15 to 30 for our automatic instruments. But we can also see, if we look at the far right column, we can also see what sort of reproducibilities and repeatabilities we can expect from a visual instrument. Now, these generally are much bigger than an electronic instrument. They're very similar if you're down at the lower level. So if you're down at the 0.2 or the 2, or 10, you're going to get similar results between electronic and visual instruments. But when you start getting up to 40 or 70 on our yellow, you can see that from these standards, we could potentially have a reproducibility of 54 between one lab and the next lab. So it might be here that one lab has reported around about 20 for the yellow, and the next lab reported about 70. This is down to this loss of resolution as we're higher up in the scale. It also means that our results seem a little bit meaningless because of this variation, which is why it's better to measure at a shorter path length where we're going to get less variation in our result. If we come down to the 1 inch path length I was talking about earlier, we're then operating at around about the 12 level on that sample. So if we look in our table here at 10 yellow, we're going to then have maybe a repeatability of around about 2 on our value and reproducibility of around about 4 or 5 for our electronic and our visual instruments. Much smaller variation in our sample, much more reliable in our measurement there. What you will need to do is in your own lab measure a few samples. Maybe if you've got 2 labs, or get different people on different lathes to measure the same sample, you can then get an idea of your reproducibility within your own company and maybe look at results from other people on the same sample in different companies, maybe between yourself and your supplier, or yourself as a supplier and your customer, and you can then get a feel for what sort of differences you're going to be expecting. And then you don't need to worry too much then if you have this table in the back of your mind. You can work out, yeah, okay, they're a little bit different, but they're within the sort of tolerances that I would be expecting. So let's look at some real samples. So here I've measured 3 samples at 3 different levels, a sort of low color, medium color, and a high color. And you can see that between the visual instrument, PFXI, electronic instrument, and a model FX electronic instrument, the results are similar, but they're not quite the same. So if we think back to the previous slide and our reproducibility values, I'm expecting some sort of difference on our red at the 0.1 level to be maybe 0.1, 0.2 at the 1 level, again somewhere around about 0.2, and then when I get up to the 4 level, I'm probably expecting my repeatability to contribute maybe 0.2. And if we look across, yeah, we can see that our red value fits into that. Again, looking at our yellow value, 0.7, 0.8 level, we can expect, yeah, 0.1, 0.2 from our repeatability. At the 2.4 level, so we can expect something like maybe 0.5 in our repeatability. And then we get a little bit higher. We're looking here at 19 yellow, 17 yellow, 17.2. And looking at our table, yeah, we can expect some sort of repeatability, maybe in the realms of about 1 to 2 units, maybe a little bit more, depending on our laboratory. So you can see here that although the numbers look a little bit different, generally they would fit in with what we expect from the type of repeatabilities and reproducibilities that the standards suggest that we might have. So if we compare, what I've done in this table is I've taken the type of repeatabilities and reproducibilities and tried to put a little bit of a tolerance and on our measurement values, so I can give a sort of range of my measurements here. So I might expect my red to vary from 0 to 0.4 on a visual, maybe a little bit less on an automatic instrument. So to try and put into context, you know, what my repeatability would be across the different instruments. And what we're looking for here is that our ranges of the values from the different instruments overlap. You can see there's quite a lot of commonality between the ranges. We're getting a wider range for the visual instruments and a smaller range for the different automatic instruments. And generally, I'm seeing the same measurement values and they're sitting on top of each other. So the ranges are overlapping. So I know here that I have some good agreement. Now you may look at the table and say, well, I'm including blue value as well in with my first sample, my very light sample. You need to remember that when your sample is very light, almost no color, and sometimes the instrument might interpret the no color as a slight blue effect or a slight red or a slight yellow. So there's always a little bit of variation, but I wouldn't expect too much variation to come into that measurement. But something of, less than 0.4 is acceptable. So when we're comparing instruments, each instrument type has its own tolerance range due to the way the instrument works, how accurate it is, or how repeatable it is at making a measurement every time. Obviously, we're going to have things like your cell preparation, your sample preparation, even sometimes the operator, especially if you're on a visual instrument, because not everybody sees exactly the same. You're going to have some small differences coming in there. But generally, I would expect that results from the same instrument type are going to be similar. And if our different instrument tolerance ranges overlap with each other, then we have agreement between our results. Results outside the tolerance range might indicate we have some sort of measurement problem. Maybe one instrument is not measuring as well as the other instruments. There may be some issue in the way the sample or whatever has been prepared. So what should we do if we find some problems with our measurement? Well, first we need to make sure that we haven't got a bad measurement. So we might then retry making the measurement. Did I get the same result? Did I do something wrong the first time? Maybe I pressed the button too soon. Maybe I didn't shut the lid of the instrument while I was making the measurement, so I was getting other light affecting the measurement. Maybe I forgot to make baseline measurement, or maybe the baseline measurement was done so long ago that I really should have done a new one before I measured the sample. Did I have the sample in the correct place within the instrument? Is it towards the front in a model F? Is it towards the back in a model FX? Is it to the right hand side in the model in a PFXI? Do I have a cleanliness issue with my instrument? Was everything clean? Was the sample cell windows clean? Were the sample chamber itself clean? Now glass racks clean? Is the white standard nice? Is there no damage in it? Is our sample insert discolored? And then if we're still getting problems, we might want to look back at the conformance filter supplied with our instrument. Did the conformance, go back, do a new baseline, measure the conformance filter. Am I getting the right result? Have I tracked down whether the problem here, if I get a good result with my conformance filter, then I can assume that the instrument is working well, and the issue then is with the way the sample has been prepared. It's something to do with the sample. Can I eliminate the instrument out of this? or is it something to do with my sample? So we just need to go through and find out where the problem actually is. Okay, I think it's time to have a few poll questions.
Okay, I'm going to launch our poll now. It's a 3-part question. If you would participate, that would be fantastic. I will leave the poll up for a couple of minutes so we can see how many people participate. We still have lots of results coming in, so we'll leave it open for a little bit longer. We still have a few more results coming in, so we'll just leave it open for a little bit longer. Okay, I'm going to end the poll in 10 seconds. Okay, so thank you to everyone that participated in the poll. Looking at the results, most people are using either a Model F or a PFXI currently, with most people who are carrying out the measurements are in quality control. And how often do we reread our edible oil color measurement procedure? Most people have selected every 1 to 6 months. Peter, do you have any thoughts on those results?
Okay, yeah, it's interesting to see the mix between the different instrument types. So we seem to be half and half split between visual and electronic instruments, and it seems the majority of you here are in quality control. Yeah, so I think I'm speaking to the right people here.
That's great. So thank you for that. Peter, we'll carry on with the webinar.
Okay, so now I want to talk to you about LUVs, the Lovibond Universal Verification Standards. This is a set of 3 amber filters, and in the set of filters it comes with a certificate with 1 set of Lovibond red, yellow, blue neutral values, but we have 3 sets of tolerance ranges. So for the Lovibond Model FX, the Lovibond PFXI, and the Tintometer Model F. So as I was talking before, the poll, where I was talking about the tolerances on our different measurements. So this set of filters comes with a certificate. We have some information at the top of the certificate tells us when the measurements were made, what the temperature was, so the environmental stuff. And then we have the actual values, so this one set of values, and then we have the tolerances underneath that for the different instrument types. And those are tolerances, so tolerance ranges, they would be specific for that particular set of filters. So how do we use these filters? So there's a quick start guide with them. So if we're using them in an electronic instrument, such as the Model FX, we're going to be using them with the label at the bottom. So what you might consider upside down. This is to do with the differences in the beam height of the optics through the different systems and the different instruments. So FX, we're going to use this upside down, push it towards the back as we would normally do, take our measurement. If we have a PFXI, again, we're going to be using the filter with the label at the bottom, so upside down, we're going to push it to the right hand side in our instrument as per the operating instructions and take our reading. If we're in the Model F, we're going to operate it with the label at the top, so right way up. We're going to pull it towards the front as we would normally do, and then we're going to look down the eyepiece and we're going to make our color match and get our measurement values. So we've got our measurement values. We're going to compare them in the first instance to the certificate values. I'm expecting that they should be close, but they're not going to be exactly the same. So then we should be looking at the lower part of the certificate, so we should be looking at the tolerance range for the instrument type. So the tolerance range has sort of built in this repeatability and reproducibility that we would expect from different instruments. So we have 3 filters, so we're checking the thing at 3 different levels. We might get something that's out of range on maybe one of the filters. So we might need to look back. Is the filter dirty? Have we got a fingerprint on it? We might need to clean the filter, check our setup in our instrument. Maybe we didn't do the baseline correctly. Recheck our measurement, retry. And if it continues to be out of range, then we may have some other problem. If we're seeing the same effect, everything's out of range, say on all 3 of these LUVS filters, then we might want to go back to the conformance filter that came with the instrument, recheck that, measure that, because hopefully we're measuring that on a daily basis or at regular intervals. So we should have some data about how our instrument is performing with its own conformance filter. And if we're finding that we still have a problem with that, well, then we've probably got some sort of issue with that particular instrument or instrument type that we're using there. So we may need to get that instrument serviced or cleaned or something of that. So give us a good idea of how well our instrument is performing. So those 3 samples that I talked about earlier in the talk were actually 3 of these universal verification filter standards. And what I've put here is the certificate value with them. You can see the certificate value is a little bit different. So on that very light sample, we have that just a touch and a little bit of blue maybe creeping in there. No red component, but appearing slightly green on the sample there rather than amber in color, because it's very little color there. And our middle sample, our 2.3 yellow on our certificate, fits fairly well with what we're getting for the different instruments. And again, when we come to the dark sample here, our 17.8 is fitting pretty well. with the 19 yellow, the 17.2 yellow from the other instruments. So if we look at the tolerance ranges from the certificate, I've got up to 0.4 blue, possible on our light sample. So in sample 1, my yellow values varying maybe from 0.3 to 1.1, and a visual instrument much tighter, 0.5 to 0.9. We were reading what, 0.7, 0.8 on our sample. So everything kind of fits together there on the first sample. I had a 2.3 yellow, 2.4 yellow on the sample 2. And we've got ranges there for the different instruments, 1.8 to 2.8 on a visual, but much tighter on a FX from 2.6. So our samples are fitting in there, sample 2, sample 1. Looking at sample 3, where we had 19 yellow, 17.2 yellow, and 17.2 yellow. Yeah, we can see that we're fitting nicely into those ranges. So we can be confident that I'm getting equivalent measurements from those 3 samples in 3 different instruments that I measured them in. So just looking again at the values, I've made them green here if they've passed the tolerance range. So although the numbers may look dissimilar, if I'm looking at my reproducibility and my repeatability that I'm expecting, as shown on the filter certificate, then everything is working together. I have equivalent comparable measurements between the 3 instrument types on those 3 samples. So I can have confidence that my measurements are good. I have good agreement between the instruments, and my sample's good to go. Other things to help us, mentioned in the previous webinar, we have the Lovibond Edible Oils method book. So this has some step-by-step instructions of how we do everything. Kind of summarizes what's in all of those international standards, which is kind of, the international standards kind of written in sort of standard language, but it's not easy to understand that sometimes. So the Edible Oils Methods booklet kind of summarizes that in sort of easy language, gives you the recommended conditions, the sample preparation, how we should report results. So everything I've really talked about here in a sort of easy way that we can understand there. That brings me to the end of my talk, and we're moving now to time of questions.